It's a beautiful day today in Kovalam, and this is the first time I'm making a presentation here in India, and it's a very, very beautiful resort. I was talking to my colleagues, and he was saying it's actually a crime to be stuck here in a conference rather than enjoying the beach, okay? But we'll get to that later. So, I'm the Director of Technologies in Akamai. What this means is that, and my role primarily focus is on helping big customers, governments, banks, architectures or systems to be able to mitigate what the future actually holds and to be able to help them innovate the business and to provide e-services, right? My background has always been in security and infrastructure. I was based out of Zurich for 2 years. I was helping a lot of banks there and a lot of governments. I've moved back to Singapore and helping APJ, Asia Pacific and Japan, governments and banks as well, right? So at any one time, please feel free to stop me. I believe this is a very interactive session. I seem to hear an echo. Is it okay for you guys? It's okay? All right, thank you. I brought this down agenda into just 3 big parts. One is the web performance or the application performance. 2 is web security. And 3rd, who is Akamai, what we do, and why we're different. So first of all, web experience is actually very, very important. So a lot of public sectors that I talk to, a lot of governments I talk to would say that, hey, it's actually not that important because constituents would have to use the application anyway. That is partially true. For a few governments that I talk to, government agencies that I talk to, this is actually getting more and more important. Because to them, as they transcend beyond the paper and application and the snail post, they are moving towards the internet where they're doing applications. For example, text, filling out text forms online. If you want to fill up your education, you're submitting an education cert online. So all this is important that your constituents, your users, are able to perform that functions. Now, I'm a Singaporean, so on April 15th, I think, every year, we got to submit our tax. And without fail, every year, the last 3 days will be a huge spike in traffic that the servers might not be able to make it, right? So far, it's been okay. But if you think about it, if let's say the entire country, the entire service is inundated for the last 2-3 hours where your constituents are filling forms online, right? Because it's just a cutoff time. You need to be able to assure consistent performance, user experience, availability, even during times of extreme peak, right? It's no longer the good old days where you're okay, you go to the post office and stuff, right? We need to move towards that. Websites and everything on the internet, however, is getting very complicated. You've got very large pages, heavyweights, so instead of having just 100 kilobyte of base HTML, you've got half a megabyte, 1 megabyte, right? And then you've got a lot of maybe AJAX calls at the end, very dynamic HTML calls or HTML5 calls. How do you ensure experience is assured? How do you do that? Then you've got connectivity. Are you going to be on edge network? Are you going to be on LTE, 4G, wireless, WAN, LAN? How do you assure that as well? And the last of all, browser fragmentization and system fragmentization. It used to be in 95, when there's a lot of PCs and laptops and so on and so forth. But right now you've got tablets, you've got iPad minis, you've got iPad, whatever, big size stuff, right? You've got Asus, you've got Androids, you've got HTC, and so on and so forth. How do you ensure that your constituents are able to have a good user experience? Those are big challenges that not only governments and public sectors are facing, but also enterprises like banks and commerce, retail, and so on and so forth. Web security is also incredibly important. I will not delve too much about this, but suffice to say, this is gaining a lot of traction, a lot of attention today, right? It's not a secret. For the past 3 to 4 weeks, Hong Kong government has been under attack. It's also not secret, in 2011, the Singapore government was under attack. It's not a matter of if, it's actually a matter of when. And what I hope to share with this is to share with you what are the certain type of attack vectors that we actually saw when we helped some of these governments defend these attacks. Now, Internet of Things is here, and it's going to grow. By 2020, there are going to be 30 billion devices out there. 30 billion in 2020. As of today, there was a study done, there are already 100,000 smart devices or appliances that are actually already compromised. In an attack about 6 months back, they actually did a survey, or they did a post-mortem on the IP addresses that were actually attacking a particular application. And they found out a few of them were actually coming from a fridge. Can you imagine if, let's say, as a CIO, as a CSO, in the next 1 year or even less, you're going to tell your boss, the CEO, that, hey, we're being attacked by, let's say, for example, TVs. From a technical standpoint, how would you be able to defend against such attacks? Today, we are already being attacked by multiple PCs, devices, handheld or otherwise. In the future, we're going to be attacked by fridges, microwave ovens, cars, and so on and so forth. Two big things. One, how do you scale? Scale in terms of your operating processes, that means your people. How are you going to keep them happy? How are they going to help you defend against all of these? How can you upskill them, up-level them? That's one. Two, how do you scale in terms of bandwidth, in terms of resources? The largest attack right now, it's probably about 300 to 400 gigabits per second. Right now. However, when these devices get on, going more and more mainstream, what will the size of attacks be like? Is it going to be 1 terabit? Is it going to be 2 terabits? What kind of infrastructure and strategy do you have in mind to be able to mitigate all of this? Scale in terms of processes. You should not be panicking just because an attack comes into play. A particular government agency that I was working with, as soon as somebody says something on the internet, they will get a lot of people to look at the traffic. We're talking about hundreds of people to look at, hey, monitors like, should I be worried about the attack? What can I do with the attack? And so on and so forth. That's a typical reaction. But you think about it. These are your staff who are not operational. They are mainly consultants, they are mainly admin people, and so on and so forth. They are not cybersecurity trained. Just because somebody said something on the internet, you are getting all your people to marshal, to defend, to look at these attacks. Question, is that effective? Is that efficient? And what does it do for your people, your staff, right? So all this has to be taken into account. Then one of the best things that, and I'll talk a little bit more about it, is what is the intelligence you can gather from these attacks, right? So this is an actual slide of an actual attack against one of the customers that we have. And you definitely cannot see this from anywhere in the room. I can't even see it well. But you will notice that from this actual deck, this is a multi-vector attack. What this means is that when a particular adversary decides to attack your site, they are never about one single vector. It's not like I'm going to SYN flood you to death. No, it's not. It's going to be a mixture of layer 3 attacks, the SYN, the ICMPs, and the UDPs. It's going to be very complicated SQL injection attacks, cross-site scripting attacks. In the Olympic Games itself, in the London Olympic Games, we saw and defended 23 million attacks, 23 million, out of 40 different attack vectors. So what you're looking at are attacks coming to you of very different vectors. In an OSI world, you're talking about layer 3 above, layer 3, layer 4, and layer 7 attacks. So your strategy when you are safeguarding an agency is to think about how you're going to scale your defenses. For this particular attacks, for this particular agency, there was no chatter. That means to say, from a threat intelligence standpoint, they did not hear any like IRC channels or chat groups. They were talking about attacking this government. They were not. It was very silent. It was very coordinated. And when they attacked, they were doing various things. They were doing DDoS and they were doing layer 7 attacks. And you might like to know that DDoS attacks, although they are very sexy right now, over 80% of all DDoS attacks will come with something more malicious. That means to steal your data, change your data. It's not only about DDoS, right? It's the entire web security posture. The future landscape, I alluded this a little bit. It's about increasing size, frequency, where they're coming from, their better targeting, complexity, and persistence. All of these are very self-explanatory and intuitive. But I'd like to talk about increased persistence. In today's world, when somebody, and we know, right, APT is advanced persistent threats. The keyword actually is persistence. How when your adversaries want to attack you, they will try multiple ways to get you. How would a government agency be able to scale with that? So who is Akamai? I was talking to a colleague just now, and the impression that Akamai has is of the traditional world. That means to say we are doing streaming, we're doing media. But what Akamai is actually a global distributed platform. We are in over 92 countries, and right now over 150,000 servers in about 800 cities and 2,000 over networks. So what this means is that this is the world's largest cybersecurity defense platform. I talked about the web experience. So one of Akamai's core is to accelerate web performance across the internet. We do it via multiple ways, technologies, but we can revolve it around with maximizing the layer 3 redundant routes. We can do maximizing and optimizing the transport protocols, and as well as the layer 7 techniques, right? I'll be happy to dive straight into this later. You can call me anytime. But more importantly, I'd like to introduce this concept called a DMZ0. Now, what's the unique feature about the technology? It's actually not. It's a proxy and it's a WAF. Pretty much that's it. But it is architecture that makes it different. When I flew in from Singapore into India, the Indian immigration gateway would check me, right? Hey, do I have a valid India visa? Does my picture look the same as my passport? Whether I have any criminal record in India and probably in Singapore, and so on and so forth. They check me in India. Imagine if the India government has a way to manage, control, and operate 150,000 immigration gateways in the world, in 92 countries, such that anybody who wants to come into India will have to be checked at your country of origin. That means to say, I get checked in Singapore by the exact same policy that the Indian government decides to put in place before putting me on a plane into India. And if I'm a legitimate user, that means to say I'm a tourist or business user or have a reason to visit India, and my record is clean, they actually put me on an even faster plane into India. Then the India government here, the immigration, can check me again. Maybe a finer detail of checks. But what you have, it's a very, very scalable distributed defense architecture in the world. Another example, during the latest Ebola crisis, right, which is currently going on, if you fly into the US, you get quarantined for 21 days in US soil before they allow you to go back into the country. But they think about it. If let's say somebody is infected, you're already on US soil. Versus, hey, wherever you come from, I check your health records, whether you've traveled to South Africa, you know, and so forth, whether you have red hair, whether you have green hair, you know, whether your criminal records, before allowing you to put you on a plane and then coming into India, and you check them again. Straight away, there are multiple advantages. One is that your people, your immigration, can focus on a lot more higher value added checks. Right now, there can be a big queue where the normal checks are in place, which you have to do them, but you need not do them in such an architecture. You check them there, and then you come back here, you check them for other stuff. Your people are more skilled, you can train them on more, in the cyber world, you can train them on forensics, threat intelligence, incident response, APT, fraud, and stuff, which right now, it's very difficult to do because there's so much traffic, right? The other thing, what you can do with this is that you can actually enhance your experience. The third thing is that you can optimize your processes. If, let's say, there was a 1 terabit of attack, your teams know exactly what to do because maybe 90% of them is already blocked there, and you just have to filter the 10% or the 1% or what they actually are. Are they really good traffic or are they bad traffic? So this is a graphical representation. I did not do this, by the way, but it's quite funny. So you have your attackers being barricaded and checked at the perimeter. Now, the concept is not new. We know it. It's called DMZ. The difference is that this DMZ is not in your data center. But you can still manage your own policies and everything that you want, your configuration and everything. Now, key benefits, and these are key learning experience that these government agencies and these banks that I work with, that they share. First of all, there should be end user experience even during an attack. One of the best things I learned was from one of the US government agencies. They were actually attacked by a 200 gig attack. This was a few years back. One of the best things that they did, and they told us, is, hey, even during an attack, keep the attack running. Do not stop the attack. Let me repeat this. One of the US government agencies was being attacked by a 200 gig attack. And the agency told us, keep the attack running, do not stop the attack. We were very shocked. Why? Because normally a customer would say, stop the attack, stop it right now. But the government agency said, no, keep it running. And the reason I found out later, and I learned a lot from this, is that they said, if let's say the press knew about it, that they were under attack, they would actually, you know, put on the front page, or this agency was under attack, and so forth. At that time, the president was talking about some nuclear disarmament talks, which was really important. From a political and country standpoint, they want to keep that on the front page. They do not want to have a DDoS attack come in and dilute the messaging to the country. Thank you. I've got 2 minutes. So I thought that was really good. It was really insightful. That means to say, from a government agency standpoint, you probably want to have control over these attacks. That means to say, when an attack comes in, you want to be able to message a communication. You want to be able to report to the ministers when and how and stuff. You might not you probably want to stop the attack, but you may not want to stop it there and then, because you want to preserve the impression that your site is not under attack. Of course, the site must be functioning, okay? So you need to have a lot of muscle to fight this. I talked about this, about minimizing operational team fatigue. That was important for a few agencies already right now. It's not scalable. Every time there's an attack, you go into a fire drill, everybody gets activated to look at what? Monitors. There's nothing you can do about it. So how do you think about that, right? And intelligence and insight to the threat attacks. You want to be able to know what headers, where they're coming from, what is the payload, how they're going to attack you. And you want to compare it against different agencies. You want to compare it against the last few years. Is there a particular trend? Is it a bigger attack, right? So all these are very big learning experience that I've gathered from my customers that I hope you'll find useful. I'll be around today. If there are any particular details that you want to know, I'll be happy to talk about it. You know, minus the names of whatever governments and agencies that, you know, that has shared this with me. All right? Thank you very much.